When you think of factories, you might imagine massive production lines churning out cars, planes, or electronics. But some of the most mind-blowing work happens in factories you've probably never heard of. From the precision crafting of tiny springs to the creation of perfect lawn stripes, these lesser-known industrial processes are the hidden heroes behind the scenes. In this video, we're diving into some of the most fascinating and intricate manufacturing processes that will leave you amazed at the sheer ingenuity and precision involved. Let's start with something small but incredibly important: springs. Ever wonder how those little coils that power your pen or keep your mattress bouncy are made? Spring manufacturing is an art form requiring extreme precision to ensure each spring can do its job without breaking or losing tension. The process begins with high-tensile steel wire. This wire is fed into a machine that coils it into shape. The tension, length, and diameter of the spring are all controlled by the machine's settings. For compression springs, which you might find in your car's suspension, the wire is tightly coiled to absorb shock. Torsion springs, on the other hand, are wound in a way that allows them to store rotational energy, like the ones used in garage doors. After coiling, the springs are heat-treated to set their shape, making sure they can withstand repeated stress. Finally, each spring is tested for strength and flexibility before being shipped off to be used in countless everyday items. Moving on to something a bit heavier, let's talk about lead. In factories where lead is cut and shaped, precision is key. Lead is a soft, malleable metal, which makes it perfect for applications like radiation shielding in batteries. But handling lead isn't as simple as slicing a loaf of bread. First, the lead is melted down and poured into molds to form sheets or blocks. Once it cools and solidifies, these sheets are carefully cut using industrial cutters that can slice through the dense metal with ease. The cutting process has to be extremely precise, especially when the lead is being prepared for specialized uses, like in the walls of medical facilities to block X-rays. After cutting, the lead pieces might be shaped further using press machines, which apply tons of force to mold the metal into the desired form. The result? Perfectly shaped lead components that are ready to perform their critical roles. Next up is something that might surprise you: lawn striping rollers. If you've ever seen a perfectly striped lawn and wondered how it was done, you're not alone. Those perfect patterns aren't just a result of how the grass is cut. They're made using specialized lawn striping rollers. In factories where these rollers are produced, the process is all about creating just the right amount of pressure to bend the grass without damaging it. The rollers are made from durable materials like steel or heavy-duty plastic and are designed to attach to the back of a lawnmower. As the mower moves, the roller bends the grass blades in different directions, creating a light and dark contrast that forms the stripes. Each roller is precision engineered to ensure it rolls smoothly across the lawn, creating consistent, even stripes every time. And while it might seem simple, the design and manufacture of these rollers require careful consideration of weight, balance, and durability. Now let's dive into the world of hydraulic riveting, a process that might not be glamorous but is absolutely essential in industries like shipbuilding and aircraft manufacturing. Riveting is a way of permanently joining two pieces of metal together using a rivet, a small metal pin that holds the materials in place. In hydraulic riveting, the rivet is inserted through the holes in the metal pieces that need to be joined. Then, a hydraulic press applies intense pressure to deform the rivet, flattening its ends and locking the metal pieces together. This process creates a bond so strong that it's often used in critical structural components, where failure is not an option. What's amazing about hydraulic riveting is the precision with which it's done. The amount of pressure, the size of the rivet, and the thickness of the metal all have to be just right to ensure a secure fit. Watching this process in action with the hydraulic press exerting tons of force to create a perfect rivet, is a powerful reminder of the engineering that goes into even the smallest details. Let's shift gears to the ancient art of forging, where metal is shaped by applying heat and pressure. In modern forging factories, this age-old technique has been perfected and scaled up to produce everything from tools to automotive parts. The process begins by heating metal until it's red hot and malleable. Once the metal reaches the right temperature, it's placed between dies, essentially large molds, that shape it under extreme pressure. The metal is hammered, pressed, or rolled until it takes on the desired form. Forging is used to create parts that need to be incredibly strong, like gears, axles, and crankshafts, because the process aligns the metal's grain structure, making it denser and more resilient. What's fascinating is how quickly and accurately these massive machines can shape the metal, transforming a glowing piece of steel into a precisely engineered component in just seconds. Plastic is everywhere, and many of the plastic items you use daily were made through a process called injection molding. This method is used to produce everything from small plastic bottle caps to large car bumpers, and the factories where it's done are marvels of efficiency and precision. In plastic injection molding, plastic pellets are melted down until they become a thick, gooey liquid. This liquid is then injected into a mold under high pressure. The mold is designed to form the plastic into a specific shape as it cools and solidifies. Once the plastic has hardened, the mold opens and the newly formed item is ejected. This process can be repeated thousands of times with incredible accuracy, allowing factories to produce large quantities of identical plastic products quickly. The variety of items that can be made through injection molding is astounding, from tiny, intricate parts to large, complex shapes. Let's not forget bolts, the unsung heroes that hold so many things together. In bolt manufacturing factories, these essential fasteners are produced in massive quantities through a process called cold heading. Cold heading involves feeding metal wire into a machine that cuts it to the correct length and then forms the bolt's head by applying pressure. The bolt is then threaded using a process called thread rolling, where the bolt is rolled between two dies that carve the threads into the metal. This method is much faster and more efficient than cutting the threads, and it also makes the bolt stronger. Watching this process is like seeing a machine work magic, turning a simple piece of wire into a strong, precisely shaped bolt in just seconds. These bolts then go on to be used in construction, machinery, vehicles, and countless other applications, literally holding the world together. Last but not least, let's talk about sheet metal stamping, a process that transforms flat sheets of metal into everything from car body panels to kitchen sinks. Sheet metal stamping is all about precision and power, using massive presses to stamp metal sheets into specific shapes. In these factories, sheets of metal are fed into a stamping press where a die presses down with incredible force, shaping the metal into the desired form. The process can involve multiple stages, with the metal being stamped several times to achieve the final shape. What's remarkable about sheet metal stamping is the level of detail that can be achieved, like complex shapes, fine details, and smooth curves are all possible through this method. The speed and precision of these machines are mind-blowing, producing perfectly formed metal parts in a matter of seconds. So, next time you pick up a spring-loaded pen, admire a perfectly striped lawn, or drive your car, remember the incredible work that goes into creating the components that make these things possible. These amazing factories and processes may not always get the spotlight, but they are truly the backbone of our modern world, filled with innovation, precision, and engineering marvels that keep everything running smoothly. If you found this journey through the world of lesser-known manufacturing as fascinating as I did, don't forget to like, share, and subscribe for more mind-blowing content.